All right, so we're going to do the second part of 2.1 today, 2.2 tomorrow, 2.3 on Thursday. Then we're going to kind of wrap it all up on Friday. I'll give you guys the test review, and then you guys can start working on it on Friday because it's kind of long, but I just want to make sure you guys are ready. So if you look at this stuff right now, we're going to talk about graphing piecewise functions tomorrow. But right now we're going to talk about just evaluating them. So remember, when you evaluate, it means you're trying to figure out the answer. Okay, so if you're trying to evaluate a function at a given point or whatever, you're trying to figure out what that answer is. So a piecewise function looks like this. It's going to give you a variety of equations. Like this first equation right here, this is a parabola because it's x squared. This equation right here is just a straight line because it's linear. And then this one right here, because remember, f of x is just a fancy way of saying y. So this equation right here is just a horizontal line that says y equals 3. So what you are given here with this piecewise is 3 different graphs, but they're only talking about pieces of them. So what we do when we evaluate is we look at the parameters that they gave us. Do you see how this says to use this top function when the value that you have is less than or equal to -2? Then they're telling you to use this function when the value that you have is in between -2 and +1. And then they're telling you to use this function when the value that you're given is greater than 1. Does that make sense? You guys see how each equation has a different parameter or a different guideline? There, you guys got that? Yeah? Okay. All right, so look at this first question says f of 5. That means they want you to plug 5 into your equation. So I look at my 3 rules at the top, right? I use this top one in red when x is less than or equal to -1. I use the green one when the x that they give me is between -2 and 1. And then I use the blue one when x is bigger than 1. So if I use the number 5, where does 5 fall in that category? The red one, the green one, or the blue one? 5's greater than 1. So that means, oh, I'm going to use the function x plus 4. So you would write down to show me your work, you would write down, okay, I'm going to use the function x plus 4. So instead of x, I'm going to plug in a 5. So I say 5 plus 4. And what is 5 plus 4? 9. So you would answer the question and you would say f of 5. When I plug in 5, I get out 9. And there's your answer. That's it. So we look at the next one. I have 1/3. Where does 1/3 fall? Is 1/3 less than or equal to -2? Is 1/3 in between -2 and 1? Or is 1/3 bigger than 1? It's in between -2 and 1, right? Well, what does this say right here? Is there any place that I can plug in an x value? Is there an x for me to plug 1/3 into? Is there an x with a 3? Do you guys see one? So all this says is y equals 3. So since there's no x value for you to plug in, that is your answer. You would say, all right, when I'm evaluating using 1/3, my answer is 3. And we'll talk what that means tomorrow more on a graph because you're looking at areas on a graph between -2 and 1. That's what we're talking about here. But if you just have a horizontal line, which is just a letter for y, a number for y, whatever, if your value falls in between that area, that's just your answer, whatever this number is. So we look at the next one. I have -9/2. Well, -9/2 is the same as -4.5, right? You guys agree with that? So where does -4.5 fall? Is it less than -2? Is it in between -2 and 1, or is it bigger than 1? Yes, ma'am. Thank you, Allie. So I'm going to use the top function. So I'm going to write down, okay, Mrs. Meadows, this is the function I'm going to use to evaluate. 2x squared minus 3. So instead of the x, I'm going to plug in -9/2. So I have 2 times -9/2 squared minus 3. So now when we evaluate, guys, we have to go back to our exponential rules and stuff like that. Remember, this 2 goes to the -9 and to the 2. So I have 2 times, what's -9 squared? 81 over 2 times 2 is 4, and then I have minus 3. So we can cross cancel here. 2 goes into 2 once, and 2 goes into 4 2 times. So you have 81 over 2 minus 3 over 1. Can I combine those two just like they are right now? What do I have to get, guys, before I can subtract? Thank you, ma'am. What's the common denominator between 2 and 1? 2, right? So if I change this to 2, I'm multiplying 1 times 2. What I do to the bottom, I do where? To the top. So 3 times 2 is 6. So I end up here with 81 over 2 minus 6 over 2. What's 81 minus 6? 75. So you get 75 over 2. So you would answer this question. You would tell me f of negative 9 over 2. When I plug in negative 9 over 2, I get out 75 over 2. And there is our answer. Question. All right, let's move over here. Negative 4. Where does negative 4 fall in? Is it less than or equal to negative 2? Is it in between negative 2 and 1? Or is it bigger than 1? It is less than negative 2. So again, I'm going to use the 2x squared minus 3. So you would tell me, all right, I'm using 2x squared minus 3. And then you just plug in the negative 4. So I have 2 times negative 4 squared minus 3. We do our exponents first. So negative 4 squared is how much? 16. Good. Minus 3. 2 times 16 is 32. And 32 minus 3 is 29. So you would say f of negative 4. When I plug in negative 4, what do I get out? 29. That is it. That is it. That is it. Questions? All right, now we're going to do this down here at the bottom. It says use the function to evaluate and simplify. So we're going to do the same kind of thing, guys, same concept, but instead now you're going to plug in expressions. So they're telling me in this first example, right, they gave me this function, f of x equals 3x squared plus 5. Well, this first question is telling me everywhere that I see an x in my original equation, I need to plug in the expression x plus 2. So you would rewrite this at first, and you would say, okay, I have my 3. Instead of x, we're putting in x plus 2. And remember, that's squared and then plus 5. So do you guys see? All we did was substitute in x plus 2 where our x was. Everybody got that? And then now we're going to simplify. We're going to evaluate. If I have x plus 2 quantity squared, that means I have 3 times x plus 2 times x plus 2, and then I have plus 5. So what we're going to do is FOIL this first, then we're going to multiply by the 3, then we're going to add the 5 at the very end. We have to make sure that we simplify in the correct order. So when we FOIL this, I have 3 times x is x squared, x times 2x is plus 2x, 2 times x is plus 2x, and 2 times 2 is plus 4. And then this plus 5 is on the very end. That's the last thing that we do. So if you guys notice right here, we can combine like terms. So you still have your 3 multiplied on the outside. X squared plus 4x plus 4. And this plus 5 stays hanging out over there. Don't add the 5 yet. That's the last thing we do. So now we're going to say, okay, let's take this 3 and distribute it. We're going to multiply everything by 3. So you get 3x squared plus 12x plus 12, and then we have our plus 5. And the last thing we do here is combine right here. So your simplified answer, when I plug in f of x plus 2, when I plug x plus 2 in, I get 3x squared plus 12x plus 17. And that would be simplified. Look at the next one. There's two things here. What are they asking you to do here? Just look at this. What are they asking you to do? What do they want you to plug in to the equation the first time? Just the x. What do they want you to plug in the second time? A 3. And then we're going to combine those functions. So I look and I say, okay, I have 3. If I plug in an x where the x already is, we just rewrite it. So 3x squared plus 5. Plus, now they want me to plug in a 3 where I see the x. So I have 3 times 3 squared plus 5. Is anything going to combine with this 3x squared? Yes or no? Does anything else have an x squared with it, guys? No, so we're just going to rewrite this 3x squared out in front and just leave it. Now we need to simplify in here. So the first thing we need to do is the 3 squared. What is 3 squared? 9. Then I multiply 9 times 3, and I get what? What's 9 times 3? Okay, good. So I have plus 5 plus 27 plus 5. So we still have our 3x squared out in front. What is 5 plus 27? 32 plus 5 gives me plus 37. So when you have f of x plus f of 3, when you evaluate this, you plug it in and evaluate, you get 3x squared plus 37. Sometimes you'll come out with a numerical answer. Sometimes your answer will have x's in it. It just depends on what they're asking you to do. All right, let's look down here. Do you see the function that they gave us, x minus 3? When we evaluate here, yeah, question? Why did I do that? Because do you see here that they want us to do two different things? They want us to add f of x plus f of 3. So I took the f of x, which was the function itself. Then they want me to add to that f of 3, where I take the original function and plug the 3 in. And then we just combine like terms. Okay, all right, cool. All right, look down here, guys. The function that they gave me is x minus 3. So what do they want me to do with this x squared? They want me to plug it in where? Right there, where I see the x, right? So you literally are just writing f of x squared equals, instead of x, you have x squared minus 3. And there's your simplified function. This is just understanding and being able to plug stuff in and then simplify, combine like terms, evaluate it, make it as simplified as possible. That's all they're asking you to do for that question. Now, when we come up here, this is very important that you guys pay attention to this. Do you see how these two questions here look similar? How do they look similar? All right, they both have a 2 and an x, and they both look like they're multiplying. But if you look at this first question, the first one is telling you to take this 2x and plug it in right there for that x value in the original function. Do you guys see that? So you're going to say negative 6 times 2x plus 4. So when we evaluate this, all we do is just multiply the negative 6 times the 2. So you get negative 12x plus 4. Does everybody see that? Now the second question, what is this one asking you to do? What does the 2 out in front mean for you to do? Anybody? Distribute the 2. All they want you to do is take 2 and multiply it into x plus 4. So when I do this, I get negative 12x plus 8. Do you guys see the difference in these two answers? Are they exactly the same? No, because this question is not asking you to do the same thing. The top one in blue is asking you to take the value 2x and substitute it in for all the x's you see. The red one is telling you to take 2 and multiply it by the function. So there's two different questions that they're asking you there. Do you guys see that? Yes? Okay. All right. So what you're going to do now is you have your web assigned and you have 20 minutes, 25 minutes now. You can finish it. Mr. Cabrera is there. He can answer questions, whatever you guys have. But your test for 2-1 to 2-3 is going to be next Tuesday. So tomorrow we're going to do section 2.2. And then I should be back on Thursday. We'll do 2.3 and then we'll kind of bring it all together on Friday. I'll give you guys a test review and then you can work on it over the weekend. We'll go over it on Monday and take our test on Tuesday.